evening to everyone. Before I proceed, I would like to say thanks to Engineer Christian Inti, former Chief Executive of Ghana Highway Authority, for this opportunity to share some engineering thoughts. My thanks also go to Engineer Bernard Owusu, Highway Design Manager, GHA, for the great discussions we had leading to the structure and content of this presentation. My thanks go to Mr. Victor Kudo, IT specialist, for helping to set up and launch this presentation. Thank you, everyone who is participating today, for your time and participation. The topic for today is project implementation, looking at geometric design considerations. Today will be an introduction to the subject or to the topic, and then at another engagement, I'll follow up with a case study applying these geometric design considerations to either a completed project or an active one. I will be taking you through what geometric design is, the importance of geometric design as a process, geometric design as an output, geometric design considerations, which is the subject for today. Geometric design, also called highway design or road design, is both a process and a product. Geometric design is the planning process of selecting the visual elements of a road. It is therefore involved with the selection of route, grades, straights, curves, crossfalls, cuts, fills, cross sections, intersection type, and the like. Geometric design, also as an output, is the drawings that depict the results of this planning process mentioned. It therefore implies a packaged solution of plans, profiles, intersection or junction details, typical cross sections, detailed cross sections, and setting out information. There is this about the importance of geometric design. We say that design gives result. Any design that you do will give you some results. No design gives poor results. If you do not design before implementation, you are going to have poor results. A poor design will definitely give poor results. A good design would give good results. The geometric design process. Looking at a geometric design as a process, we would start with the considerations that we'll be talking about. The considerations inform the inputs that we would use. Then we would use tools such as software and hardware to generate the outputs of the selected route, drawings, volumetrics, and setting out information. You can review the diagram. Considerations lead to the selection of inputs. We work through tools, and then we have outputs. To make it a closed system, after the outputs, feedback from reviews and stakeholder engagements will be run through considerations, and then we are back to the beginning to generate improved outputs. Considerations mentioned are the likes of functionality, route location, safety, site conditions, terrain type, land use, mobility, access, traffic volume, traffic composition, stakeholder interests, climate resilience, and economy. The output of geometric design, or geometric design as an output, brings us typical cross sections, horizontal alignment, vertical alignment, intersections, expropriation drawings, volumetrics, and setting out information so that the design, after setting out, can be implemented or constructed. Now, what are geometric design considerations? Geometric design considerations govern the design process. As described earlier. Geometric design considerations determine the quality of the design output. They are factors that are considered in order to improve the quality of the design output. If you have not considered it, you are not likely to make provision for it in your design. Geometric design considerations are obtained from terms of reference, documents, design manuals, stakeholder consultation, and lessons learned. For stakeholder consultation, for instance, a rock sitting close to the existing alignment on the Fufusu Solar Road at Larabanga was the mystic stone. It was not an ordinary rock that could have been destroyed or moved aside, shoved aside. But upon consultation, it was realized that it was the mystic stone, which led to the modification of the alignment to avoid it, and the creation of access and parking area to serve it. For lessons learned, the failure of road pavements, for instance, in traversing low-lying areas by reason of high water table, leads to higher embankments through such terrain on subsequent projects, for instance. Also, the high rate of fatalities and delays for alignments going through settlements informs the creation of bypasses and elevated highways. Now, the geometric design considerations. There's this table I would like us to consider. In the first column, we have the design considerations. The second column houses the issues emanating from the design consideration. The third column is the involvement or the ranking. I mean, how intensely we use these design considerations at the planning stage. And then the last column is how they feature at the implementation stage, which is a focus for today. Functionality is one key design consideration. And for functionality, we are thinking of how much free flow do we want on the road intended? Is it going to be a trunk road? Is it going to be an urban road or a feeder road? What are the parking demands? High parking or layover demand would lead to the inclusion of things like lay-bys and parking strips. At the planning stage, there's a lot of focus. The planning stage is where these considerations are very highly rated and worked on. However, at the implementation stage, that is where we review everything we have done by way of geometric design, and then see whether we are still going to meet our objectives and so on. So functionality still plays a role at the implementation stage. Route location involves issues such as connectivity and the total length. I mean, in route planning or route location, what are the urban or market centers to be connected? Are there any swamps, mountains, valleys, water bodies to be avoided? the total length that we would arrive at suggests the total travel time. It also suggests delays and suggests the cost of the project. Route location by implementation stage, obviously, yes, we'll still be considering it. However, a lot of that would have been done at the design stage. There's an active project we are doing, and at the implementation stage, we have discovered that a part of the alignment is coursing through a mining concession, and so we have had to change the route, modify the route. Traffic volume is the next design consideration. For traffic volume, we are looking at issues like the number of lanes, intersection configuration. At the planning stage, we devote a lot of energy to that, but still at the implementation stage, we are reviewing what we have done to ensure that we meet the objectives. So intersection types can be modified at the planning stage based on the traffic volume and changes in traffic volume, traffic stream patterns, and the like. Traffic composition is the next. Over there, we are looking at things like the percentage of heavy goods vehicles or trucks. We are looking at percentage commercial vehicles. We are looking at the presence and volumes of pedestrians, cyclists. Design vehicle comes out of that. Because if you have a high percentage of trucks, then you are likely for your intersections and for your lane configurations to use the large vehicle as a design vehicle. Capacity is the next consideration, where we look at the level of service, percentage time following, delay, and queue length. At the design or planning stage, I mean, we give it maximum consideration, but at the implementation stage, we are still looking at whether we are achieving our objectives. On one of our active projects, during the design stage, we did not have that much access demand from adjacent or adjoining properties. But during implementation, we noticed that it has become a very thorny issue and worrying issue. So at the design stage, we would have individual accesses adjoining the project road. But now, for capacity, we are now having to group these access requirements by the creation of frontage of service roads. Safety is the next. For safety, we are looking at vulnerable road users. We are looking at black spot elimination. We are looking at alignments. Can we safely go over hills? I mean, our crest curves. Can we safely go around objects, our horizontal curves? And they become pertinent issues, not only at the planning stage, but also during the implementation stage. Safety is everything. There are sections where you have to reconsider the provision of elevated pedestrian walkways. You have to consider the provision of footbridges, because at the implementation stage, this has become an issue. The next is site conditions. For site conditions, we are looking at swamps, water bodies, soft spots, and so on. Any given terrain type, for instance, informs the selection of design speed, earthwork volumes. At the planning stage, design considerations are the focus of today's presentation. So I would like to go back to the previous table. So this is what we were looking at. The first column is the considerations themselves. The second column are the issues emanating out of these considerations. The third column is the weighting at the planning stage. And the last column is the weighting of this design consideration at the implementation stage. And so we were talking about functionality, route location, traffic volume, traffic composition, capacity, and then safety. So what we said about safety, for instance, was that safety is virtually everything. It's one of the high-ranking considerations. So you will see that at the implementation stage, we are still heavily considering safety in all our alignment geometric choices. Safety at intersections, safety of the alignments themselves, and a black spot elimination and vulnerable road users. Have we catered sufficiently for pedestrians? Have we catered for them by way of footbridges, elevated sidewalks, and so on? So I move to the next slide. Yes. So site conditions, terrain type, land use. Yeah, land use, mobility, stakeholder interests, climate resistance, and economy are the next group of design considerations. For terrain type, we said that any given terrain type informs the selection of design speed, and it also informs earthwork volume. So at the implementation stage, for proper cost management, it will be useful to keep looking at the terrain type vis-a-vis the design speed. Often the design speed, we have a range. And so you use the lowest possible when it becomes necessary to keep things within cost, of course, with a view to safety. Terrain type, that was it. The land use, are there any heritage sites? Are there built up areas? Do we have utility lines, mining concessions, planning schemes? What are they saying now? And at the design stage, of course, we do everything that we can. However, at the implementation stage, new things always crop up. An area that didn't used to be built up could become built up physically or planned to be built up. Emergent utility lines would have to be managed. On active projects, you may have to look at the geometry once again as a way of avoiding or managing utility lines. You either avoid them completely or you shift your center line and other things such that probably they fall under pedestrian walkways where that can be done. If there wasn't a mining concession and there now is, of course, you would have to modify the geometrics to either avoid the concession totally or to go through it without disturbing mining operations. The planning schemes, land use, at the stage of designing, the planning scheme may say one thing, but then at the implementation stage, it may say another thing that would inform geometry. Mobility and then access. Mobility versus access priority. Is it a trunk road? How much free flow are we expecting? How much connections, accesses to our trunk road do we want? Is it an urban arterial? Is it a major arterial? Is it a minor arterial? There's always a consideration of the balance between mobility and then access. To balance the two properly so that you have appreciable mobility and then access. Often the geometry would have to be considered to have frontage roads alongside the main roads or service roads. Stakeholder interests. We look at socioeconomic activity, access to facilities and points of interest. At a design stage, we are looking at how easily communities can access health facilities, market centers, and so on after our design. And at the implementation stage, these remain issues. If at the design stage, there didn't appear to be the need to connect a residential area to the road we are designing, we have to look at it again during implementation. We may realize that we may have to provide connections or to modify the alignments to facilitate access. So we don't kill settlements or their livelihoods. Climate resilience is the next. We bring up issues like pollution, deforestation, environmental stability. At the design stage, it is, a heavy thing to be considered, but still at the implementation stage, we look over our work with a view to climate resilience and certain modifications. Are we by mistake, some mistake, going to erase a pond or wetland that houses some particular bird species or animal species, or flora and fauna? Can we modify it? The trees that our geometry is affecting, what can we do? Can we minimize deforestation, or what are the mitigation measures? All of these are geometric design considerations. The last amongst the considerations is economy. Every alignment choice that we make, every typical cross-section choice that we make impinges on economy. And so at the design stage, this is one of the highest considerations, and the ranking is very high because we are looking at the net present value of the project. We are looking at benefit to cost ratio in the area of cost efficiency. During implementation, we still take decisions in this area to keep costs within budget. And some of them a lot of them will be in the area of geometric design. The design considerations presented here are by no means exhaustive, but they are definitely key design considerations. At this moment, I would want to say thank you, and then open the floor probably for contributions, submissions, discussions, questions. Thank you.